Hello, everybody. How are you all doing? It's me, Mourad Sultan Ezouidi, the pioneers in Memphis. Okay, today we are going to solve the from equation using the theorem of Mourad Sultan Ezouidi. Okay, let's see first. Okay, so as we talked about today, we will try using Ezouidi theorem so that to find the exact roots of these A-level degree from the equation is not easy, in fact, but it's an occasion for you, learners, students, professors, to deal with this kind of questions. Okay, so let's start. First of all, you try to find okay 11 degree. Where is 11 degree down? So prepare yourself, prepare your paper sheets and calculators so that you will work with this 11 degree from the equation. Okay, let's start. Okay, I'm also using my scientific calculators so that I can calculate the coefficient of the new 11 degree from the equation. Okay, relative to the original 11 degree from the equation. Okay, my kids. So let's start. Prepare yourself first. Okay, then we are going to start. Okay, this is my kids opening to the power 11. Okay, this is the previous example that we had solved and found that say its exact roots. Okay, without error estimation, without let's say bad method like approximation method like the Newton method or other methods that will give you wrong answers. Okay, according to me, to my theorem, we can now work through the from equation and find the exact roots. Okay, let's just go step by step. I'm going to rewrite again my 11 from the equation, and I will start solving it and find its exact roots. Okay, means there is no error of estimation and there is no approximation method. Okay, so let's just start, my kids. Prepare yourself and write the 11 from equation that you are going to start solving it. Okay, let's go step by step. Okay, this is our this is our 11 from equation. This example we did before, my kids. Now we are going to solve a new polynomial called this is when n equal 10 because k, let's say, ranges from -1 to 10. Okay, the last coefficient is 10, not 11. Okay, prepare yourself. Now the example will be in front of you, and you can see it. Okay, this is our to the power 11, this one. Okay, now my kids, you see this polynomial equation raised to the power 11. I'm going to read it. Example number 2. P of x equal x raised to the power 11 minus 11x raised to the power 10 plus 55x raised to the power 9 minus 165x raised to the power 8 plus 330x raised to the power 7 minus 462x raised to the power 6 plus 462x raised to the power 5 minus 330x raised to the power 4 plus 165x cubed minus 55 x squared plus 11x minus 1. Okay. Now, my kids, this is our 11 degree from equation, means that this is our original 11 degree from equation. In order to solve this, we should use Ezouidi theorem that will give us, let's say, the coefficient of our new 11 degree from equation, okay, where the coefficients are s subscript minus 1 for the cube, as subscript 0 for the cube, s1, s2, s3, s4, up to s10, okay, because n is going to be equal to 11 and k minus 1 will be 11 minus 1 gives you the last coefficient and 10 for the cube. Now we'll try to rewrite again or find, let's say, our 11th degree from the equation, and then we are going to make conclusion and find the exact roots, okay, without error estimation and without using approximation method. So it's me, Mourad Sultan Ezouidi, the pioneers method, Indonesian mathematics teacher, okay, is now working with his own theories or theorems that will lead you to find the exact roots, okay? So as you can see that, in fact, let's focus on this one to the power 11. To find out the roots of this polynomial, we will determine the values of SR for the Q. SR means the coefficient of the new 11 degree from the equation. Of course, relative respectively to LR for the Q, where R belongs to the set of numbers minus 1, 0, 1, 2, 3, 4, 5, up to 10. Okay, let's start, my kids. So the coefficient of my original polynomial equation has to be written as the following. Okay, let's go step by step. So we told L0 in fact is going to be 11, L1 is 55, L2 is going to be 165, L3 is going to be 330, and L4 is going to be equal to 462, L5 is going to be also equal to 462, L6 is going to be equal to 330, and L7 is going to be equal to 165. And L8 is going to be equal to 55. L9, 11, and L10 is going to be equal to 1 because the last coefficient is equal to 1. Okay. Now, after calculating or finding, let's say, the new coefficient of the new 11 degree from equation using Ezouidi theorem, we will we will come to write this as that. So here you are going to professors and learners to use this kind of formula of Mourad Sultan Ezouidi, which is equal to S subscript k minus 1 of all the q. Of course, k ranges from 0 to n minus 1, like k means from 0 to 10, because n is going to be equal to 11, so n minus 1 is 10. So the last coefficient of the new 11 degree from equation has to be equal to S order S subscript 10 of the q. Okay, this formula has to be applied, okay, for all, let's say, for all the values of k, so that you can find S1, S2, S3, S4, S5, and up to S10. Okay. After that, you are going to calculate, you will write your new 11 degree from equation as in its standard form, x raised to the power 11 minus s0 for the q x raised to the power 10 plus s1 for the q x raised to the power 9 plus s minus s2 for the q x raised to the power 8 up to minus L0 for the Q. Okay, so we go step by step. I'm going now to substitute K equal 0 in the discount formula B, and we will obtain that, in fact, S minus 1 for the Q by convention is equal to 1. Okay, so this is when putting K equal 0. So the coefficient S subscript minus 1 over the Q, y simply because K equals 0, it will be 0 minus 1, which is minus 1. So this one has to be equal to 1. Okay, we continue our procedure, my kids. Okay, sorry. Okay, again, yes, this one. Okay, we continue our procedure so that we can find S0. S0, my kids, we thought before that it is equal to the sum of the x roots of this new 11 degree from equation. It means S0 for the 2 is equal to x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x8 plus 7 plus x8 plus x9 plus x10. These has to be equal to 0. Okay. Now we, in this example, we should find the value of x1 up to x10, okay? Meaning the axioms of these new 11 degree from equation relative to the original 11 degree from equation. After that, we will make our conclusion and we'll write that alpha subscript k equal L0 for q plus the axioms, let's say x subscript k, all divided by n. N denotes here the highest power of this polynomial, which is equal to 11. So it will be alpha subscript k equal L0 for q plus xk divided by 11. okay, simply because the highest power here is equal to 11. Now, my kids, I'm going to find, let's say, we told that 0 is equal to combination 11 choose 1, okay, negative sign times 11 plus 11 times 11, which is equal to negative 121 plus 121. This one, okay, the sum of this has to be equal to a now, okay. So we proceed, we continue. I'm going to substitute k equal 2 with the discriminant formula of Mourad Sultan Ezouidi as subscript k minus 1 equal I equal the sum from 0 to k combination n minus r choose k minus r and raised to the power r between parentheses negative 0 for q raised to the power k minus r times and subscript minus 1 for the q. After making our calculation and simplifying this expression, I'm going to use the last one, which is negative combination 2 1 choose 1 times combination n choose 2 times L0 for 2 squared plus n squared times L1. This one, my kids, I'm just use the first coefficient. Sorry. Okay. I'm going to use the first coefficient L0 for Q, which is 11, and L1. Okay, because this formula depends only on these two values. Okay. So you can use the calculator's learners. Of course, this one is going to be equal, L10 is going to be equal to 1. Okay. And here also is going to be equal to 1. I'm going to change this. Okay, so I'm going to substitute in the second formula to find, let's say, the second coefficient of this new 11 you get from the equation. This one, okay, is one of all the combination 11 choose 2, which is in fact 55 minus 55 times 11 squared plus 11 squared times 55. It's going to be clear, my kids, that is equal to an hour, okay? Or you can note that 11 squared is a common factor here. So we don't put in consideration, just make a calculation, make negative combination 11 choose 2, which is 55 plus 55 is equal to 0. So no need to multiply by the square of 11 simply because the answer is going to be equal to 0, okay? Now I'm going to proceed to continue to find, let's say now my kids, to find exactly, start here, yes, to find the S2. So put k equal 3 in the discrete formula of mean, and we'll come to reach the uh, the lowest, the formula that had been written in its lowest form, which is equal combination 2 choose 1, okay, times combination n choose 3, and denotes the highest power of my polynomial, which is 11, times L0 for q cubic minus combination n minus 2 choose 1 n squared times L0 for q times L1 times plus n cubed times L2 for q. Now I'm going to use my calculator, and you also, my kids, you can use the calculator as soon as possible. I can figure out the value of this. So I'm going to substitute here, and um, we'll see that S2 of the R is equal to combination 3 choose 1 times combination 3 choose 3, 11 choose 3 times 11 cubic minus combination n choose 1 times 11 square times 11 times 55 plus 11 is cubed times 165. Learners, you can see that 11 cubed is a common factor. So ignore this step, okay? This is 11 cubed. This is 11 cubed. Just write the sum of the combination 2 choose 1 times combination choose 3, 11 choose 3 minus combination n choose 1 times 55 plus 165. So this one uh, by convention is going to be equal to 0. Okay, you can use the scientific calculator. Okay, so S2 equals 0. Now we continue to find S3, my kids. You have to put K equal 4 if the discrete formula of Mourad Sultan Ezouidi, and then after, let's say, writing your formula in its lowest form, you are going to say that, or to write that S3 of the R equal negative combination 3 choose 1 times combination n choose 4 times 0 for the q raised to the power 4 plus combination n minus 2 choose 2 times n squared times 0 for 2 squared times L1 minus combination n minus 3 choose 1 times the cube of n times the cube of 0 for the cube times 2 for cube plus n raised to the power 4 times L3. Of course, here the last coefficient here is going to be equal to 1, not 78, because this example we did before. So we continue, my kids. We, let's say, we can note that S3 in fact is equal to now equal to 0. You can use calculator and calculate S3, okay? And you can note that 11 raised to the power 4 is the common factor. Put it into consideration and put it as a common factor and just calculate negative 3 choose 1 times 11 choose 4 plus combination 9 choose 2 times 55 minus 8 choose 1 times 165 plus 330. With this one, in fact, we're going to be equal to 0. Okay, we go step by step so that the question why we are going to using this theorem, because this theorem will give you the coefficient of the new level equation that corresponds to the original level equation. Okay, that will give you the relationship between the roots, the exact roots of our original 11 degree equation and the exact x roots of the new 11 Newton equation. Okay, so now I'm going to use put or set k equal 5 in this chemical formula of me, and we'll okay, now put k equal 5. We obtain my kids. Of course, we are going to put k equal 5 in this formula of Mourad Sultan Ezouidi, and you will reach or you will reach yes S4 for the Q equal combination 4 choose 1 times combination n choose 5 times and 0 for the 2 raised to the power 5 minus combination n minus 2 choose 3 n squared times n 0 for q cubed times n1 plus combination n minus 3 choose 2 n cubed times n 0 for the 2 squared times n2 minus combination n minus 4 choose 1 times n raised to the power 4 times n 0 for 2 raised to the power 1 times n3 plus n raised to the power 5 times n4. You just use, we are going to use this formula L0 to 11, L1 to 5, L2 is 165, and L3 is going to be 330 up to L4, which is equal to 462. Because this formula gives you the fifth coefficient of your new 11 degree from equation that corresponds to the original 11 degree from equation. There is a relationship between that and this. Okay. Now, my kids, you can note that the last coefficient is equal to 1. Okay, I'm going to, yes, this is 1. So by calculation terms, I'm going to substitute in this formula with L0 11, L1 with 55. Of course, L0 to the power 3 is 11 to the power 3. And let's say L1, L2 is 165, L3 is 330, and L4 is 462. You are going to use a calculator and you will see the value of S4 or the fifth coefficient of our new 11 degree from equation in fact is equal to a now. Okay, we continue the procedure so that we can find S5. Okay, the same here, we are going to substitute k equal what, make it substitute k equal 6 in the discrete formula of Mourad Sultan Ezouidi. Let's substitute k minus 1 equal r equal the sum r ranges from 0 to k. Okay, k here is 6, means we are going to put here 6 and minus r and first, and write in its standard form, and in its simplest form, then you are going to make your own substitution. Okay, so you are going to see that S5 for the R equal negative combination 5 choose 1 times 11 choose 6 times 0 for the 2 raised to the power 6 plus combination 9 choose 4 and squared and 0 for the 2 raised to the power 4 times 1 minus combination 8 choose 3 times and cubed times 0 for the 2 cubed times into plus combination 7 choose 2 and raised to the power 4 times and 0 for the 2 squared times and 3 minus combination 6 choose 1 which is 6 and raised to the power 5 times and 0 for the 2 raised to the power 1 times L4 plus n raised to the power 6 times L5. We are going to use all the coefficient from L0 up to L5, which is equal to 462. It means you are going to use all the previous coefficient of our original 11 degree from equation. Of course, the last term here is going to be equal to 1. I'm going to change this one. Okay. Now, after calculating this, my kids, you are going to find that S5 in fact is equal to 0, okay? You can use calculator, you calculate this, okay, and you are going to see that S5 equal to 0. Now, my kids, in order to find, we found that S minus 1 is equal to 1, S0 is equal to 0, S1 equals 0, S2 equals 0, S3 equals 0, and S4 equals 0, and S5 equals 0. Okay, so it remains only S6, and S7, and S8, and S8, 9, and 10. Okay, so 4 steps. We are going to go step by step. In order to find the S6, my kids, you are going to put K equals 7 in this formula only, which is equal to the subscript k minus 1 for the r. K is 7, ik. The sum from 0 to k, combination n minus r choose k minus r, n raised to the power r, between parentheses, negative 0.2 raised to the power k minus r, times n subscript n minus 1 for q. Of course, r is going to be from 0 to k. The k here is equal to 7. So, here it will be okay from 0 to 7. Okay. Now, after writing our formula in its lowest term, so we can see that, or we can say that S6 for the R equal combination 6 choose 1 times combination 11 choose 7 times L0 for 2 raised to the power 7 plus or minus combination 9 choose 5 that is squared L0 for 2 raised to the power 5 times L1 plus combination 8 choose 4 n raised to the power 3 L0 for 2 raised to the power 4 times L2 for 2 minus 7 choose 3 n raised to the power 4 in the cube of L0 for 2 times L3 plus combination 6 choose 2 n raised to the power 5 times L0 for 2 raised to the power 1 times L4 of all the cube minus combination 5 choose 1 times n raised to the power 6 times L0 for 2 raised to the power 1 times L4 plus n raised to the power 7 times L6 means this formula will give you the seventh coefficient of your new 11th equation, and you are going to use only the coefficient of your original 11 polynomial equation, degree polynomial equation, which is 11, 55, 165, 330, 462, and 462, and 330. Means you are going to use all this seventh coefficient of our original degree polynomial equation. Of course, the last coefficient here, my kids, is going to be equal to 1. I'm going to replace this 78 with 1. Okay. And you can note that, you can see that 11 raised to the power 7 is a common factor. No need to use it or to type it in your scientific calculator. Just put it, let's say, as a common factor and open the parentheses and just calculate the rest. So after calculating and using your scientific calculator, you can see that the value of a 6 here is going to be equal to a null. Okay. We continue the procedure. Here we want to find a 7. To find a 7, my kids, you should go to use the Ezouidi theorem that is labeled as the discriminant formula of Mourad Sultan Ezouidi, okay, which is equal to a subscript k minus 1 for the r, the sum from 0 to k, combination, let's say, of, combination n minus r, replace move here, okay, sorry, okay, I need this. So, and minus L0 for the q raised to the power k minus r times L subscript r minus 1 for the q. After, let's say, developing and expanding this formula, we should write a 7 as negative combination 7 choose 1 times combination 11 choose 8 times a 0 for the q raised to the power 8 plus combination 9 choose 6 times the square of n times L0 for the q raised to the power 6 times 1 minus combination 8 choose 5 n raised to the power 3 times L0 for q raised to the power 5 times L2 plus combination 7 choose 4 times n raised to the power 4 times L0 for the q raised to the power 4 times L3 for the q minus 6 choose 3 n raised to the power 5 times L0 for the q raised to the power 3 times L4 for the q plus 5 choose 2 n raised to the power 6 L0 for the q squared times L5 minus combination 4 choose 1 n raised to the power 7 times L0 for the q raised to the power 1 times L6 for the q plus n raised to the power 8 times L7 for the q means you are going to use these coefficient, okay, except L8 and L9 and L10, which is equal to 1. Okay, I will replace this with 1. Okay, what is it? I'm going to wait. Okay, this is with all 1. Okay, now you can see that in fact 11 raised to the power 8 is a common factor, isn't it? Is a common factor. Okay, is a common factor here. This is S7. Okay, just replace L0 with its value and L1 with its value and S2 with its value, L0, L2, sorry, and L3, L4, L5, L6, and L7. So use a calculator. You will see that S7 equal to an hour. Okay, we continue to find S8, my kids. You have to put or set K equal 9 with this formula with me. Okay, the formula or the theorem is written as that S subscript K minus 1 over R equal the sum from 0 to K combination N minus R. Choose K minus R and raised to the power R between parentheses negative L0 for the 2 all the raised to the power K minus R times L subscript R minus 1 for the 2. Okay, after developing this formula, you are going to use the last one, which is this one, S8 equal combination A choose 1 times combination N choose 9 and 0 for the Q raised to the power 9, okay, up to N raised to the power 9 times N8. So you are going to use this coefficient. So L10 we told that is equal to 1. Now after, let's say, simplifying or replacing or substituting L subscript K minus 1 for the Q up to 7, means from 0 to 7, you will find that the value of S8 is equal to 0. Okay, and you can note that 11 raised to the power 9 is a common factor. Okay, so no need to write it. Just calculate the 8 choose 1 times 11 choose 9 minus 9 choose 7 times 55 plus 8 choose 6 times 165 minus 7 choose 5 times 330 plus 6 choose 4 times 462 minus 5 choose 2 times 5 choose 3 times 462 plus 4 choose 2 times 330 minus 3 choose 1 times 165 plus 55. Okay, you will see that is equal to 0. Multiplied by 11 raised to the power 9, of course, has to be equal to 0. We continue, my kids, like professors, so that we can rewrite, let's say, my new 11 degree from the equation relative to this original 11 degree from the equation. Okay, just set k equal 10 in the theorem of Mourad Sultan Ezouidi. I will give you 30 seconds to think of that and find, let's say, the general formula that will help you to find the 10th coefficient of this new 11 degree from equation relative to the original 11 degree from equation. So, and after calculating, we will see that our new 11th from equation has 11th root, okay, of order of multiplicity of 11th, or where 11 is the order of multiplicity, means that you can write your new 11 degree equation as x minus a all raised to the power 11. Okay, whatsoever the value of a, we will see that is in fact equal to 0 after finishing. So now I'm going to substitute L10 will equal to 1. Okay, now I'm going to proceed and I'm going to calculate, let's say, S9, which is equal to negative combination I choose 1 times combination n choose 10 times L0 for degrees to the power 10 plus combination n minus 2 choose 8, the square of n times L0 for degrees to the power 8 times L1 of 40 cube minus combination n minus 3 choose 7 n cubed L0 for degrees to the power 7 times L2 plus combination n minus 4 choose 6 n raised to the power 4 times L0 for degrees to the power 6 times L3 for cube minus combination n minus 5 choose 5 n raised to the power 5 times L0 for degrees to the power 5 times L4 plus combination n minus 6 choose 4 n raised to the power 6 times L0 for the q raised to the power 4 times L5 for the q minus combination n minus 7 choose 3 n raised to the power 7 times L0 for the q cubed times L6 plus combination n minus 8 choose 2 n raised to the power 8 times L0 for the q squared times L6 for the q minus combination n minus 9 choose 1 n raised to the power 9, L0 for the q raised to the power 1 times L6 for the q plus n raised to the power 10 times L9 for the q. Means here you are going to substitute L0 with 11 and L1 with 55, L2 with 165, L3 with 330, L4 with 462, and L5 with 462, L6 with 330, and L7 with 165, and L8 with yes 55, and L9 with 11. So after calculating, okay, or type this in your scientific calculator, you will see that S9 here is equal to 0. Okay, now we reach the last step when k, okay, just a moment, this is k equal 10, yes, this is k equal 11. Okay, when k equal 11, you are going to find s k minus 1, which is s10. Okay, so meaning that you should put k equal 11 in the decimal formula of Mourad Sultan Ezouidi, and you will come to write the the formula in its lowest term, that is equal to, what is it here, s10 of order r equal 10 choose 1 combination n choose 11, and n is going to be 11. 11 choose 11 is 1, but this has to be written in the formula. And 0 for the q raised to the power 11. Okay, this is raised to the power 11. I'm going to correct this. Okay, then, okay, yes, then my kids combination plus combination and minus 2 choose 9, and minus 2, 11 minus 2 is 9, choose 9 is 1, but this has to be appear in the formula. So because it's available, or this formula has been generalized for any n degree from equation whatsoever, n equal 12, 30, 40, 60, 100, 1000. So this S10 will give you the 11th coefficient of your n degree from equation whatsoever the degree of the polynomial equation that you are working or trying to solve it. Okay, then we told the minus plus combination and minus, which was 9 n squared times L0 for the q raised to the power 9 times L1 minus combination n minus 3, which is 8, and the n cubed L0 for the q raised to the power 8 times L2 plus combination n minus 4, which is 7, n raised to the power 4 times L0 for the q raised to the power 7 times L3 minus combination n minus 5, n is going to be 11, 11 minus 5 is 6, 6 to 6 is 1, but this had been written or had been generalized for the 11th coefficient for any nth degree from equation. Okay, times nq n raised to the power 5 times 0 for the q raised to the power 6 times 4 plus combination n minus 6 choose 5 n raised to the power 6 times 0 for the q raised to the power 5 times L5 minus combination n minus 7 choose 4 times n raised to the power 7 times 0 for the q raised to the power 4 times L6 of all the q plus my kids n minus 8 choose 3. You can see that n minus 8, 11 minus 8 is 3, 3 choose 3 is 1. Okay, n raised to the power 8 times 0 for the q raised to the power 3 times L7 minus combination n minus 9 choose 2 times n raised to the power 9 times 0 for the q squared times L8 plus combination n minus 9 choose yes choose 1 n raised to the power 10, this one n raised to the power 10, okay, times 0 for the q times L9 plus n raised to the power 11 times 10. So here the last coefficient that is equal to 1. Okay, now my kids, I'm going to try to calculate the value of this. Okay, so this we call this is 10 in fact. Okay, n raised to the power 10. No, comes like that. Okay, of course here has to be changed 11th and raised to the power 10. Okay. Okay, 8, 7, 6, 5, 4, 4. Okay, 3, 3. Okay, and 9 and 10. Okay. So I'm coming here and replace this with combination. Yes, it's written here 10. 11 raised to n is 11. 11 raised to the power 10. Okay, and then this one has to be equal to 1. You can calculate this, so you will find that is equal to 0. I'm going to use my calculator. This is my kids is going to be equal to 0. Okay, let's see this one. So I'm going to use my calculator, scientific calculator. Okay, and calculate this. This is my scientific calculator. Calculator. Okay, good man. Now you can see that. Okay, 11 choose 11 is 1. I'll just write 10. Okay, 10. Then minus 55. Minus 55. Minus 55. Good man. Minus, where is it? Minus 55. Plus 165. Plus 100 minus 330. Minus 330. Okay. Plus 462. And then we have minus 462 because 11 raised to the power 11 is going to be a common factor. 5 choose 5 is 1. I'll just write minus 4 minus 462, 462 plus 330 minus 165. Okay, plus 55 minus 11. This one minus 11. Minus 11. Minus 11. Plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus, plus 1, plus 10, plus 1 is equal to 0, you see? So, means that all the coefficient of our new 11 degree from equation are equal to 0, okay? So, after that, as we make our conclusion, we found, let's say, that all s subscript k minus 1 of order r equals 0, means I'm going to write my new 11 degree from equation that has to be written as x raised to the power 11 minus s0 for the cube raised to the power x raised to the power 10 plus s1 for the cube x raised to the power 9 minus s2 for the r x raised to the power 8 plus s3 for the r x raised to the power 7 minus s4 for the r x raised to the power 6 plus s5 of order r x raised to the power 5 minus s6 of order x4 plus s7 x cubed minus s8 x squared plus s9 for the r times x minus s10. All the coefficients are equal to 0. Therefore, I will write this as that. You see that? X, okay, x11 equals 0 means xk are equal to 0, okay? Means that xk are equal to 0, okay? Means I'll just write here equals 0 and I will erase everything, okay? Okay, so this is as x raised to the power 11 equals 0 means x subscript k from 0 to 10 are equal to now. Therefore, let's say the exact these are the exact roots. The x roots are I'll just write are okay are the exact x roots sorry x roots of my new 11th degree degree, okay, degree polynomial equation. Polynomial equation relative to what? Relative to relative to the original 11th degree polynomial equation that I started with from the beginning. Okay, let's okay, equation. Okay, I got. Okay, so my kids here, I'm going to write. You see, I already found now these are called exact. The exact x roots of the new 11 degree polynomial equation. To find now, my kids, the exact roots of the original 11 degree polynomial equation, just we'll use the relationship between the original and the new 11 degree equation that has to be written as that 0 for the cube plus x, which are the x roots of the new 11 degree from equation. Uh, Subscript k ranges from 0 to 10. Okay, from 0 to 10. Okay, to 10. Okay, all divided by 11. Therefore, we told that the x roots are going to be equal 0. You see, the x roots are going to be equal 0. This is the x roots. X subscript from 0 to 10 is equal to 0, simply because x is to the power 11 equal 0. Okay? Now, my kids, I'm going to substitute with the x subscript k from 0 to 10 with 0. Okay? Okay, like that. Okay, good man. So 11 over 11 plus 11 plus 0 is 11 divided by 11 is going to be equal to 1. Means what, my kids? Means what? What is the equation? This means that, okay. This means that, okay, okay, means that alpha, I will make alpha, it's better, yes, alpha equal 1 is a root, is an exact root, is an exact root, is an exact root, okay, of of order, of order, of, of okay, where, I'll just write down, yes, where 11 is its order of multiplicity, its order of multiplicity means that our original polynomial equation, in fact, is written as x minus 1 all raised to the power 11. Okay, means that, my kids, that our polynomial equation, our original polynomial equation, in fact, is equal to x minus 1 raised to the power 11. So the roots are the exact roots. You can see that when let's say you are working with, this is of course is 10, okay? When you are working with polynomial equation, with an nth polynomial equation, where n is its order of multiplicity, means that you are going to write your equation as x means alpha all raised to the power m. Okay, to find the new nth degree from equation, so the coefficient of your nth degree from equation, all of them are equal to 0 except s minus 1 by convention is equal to 1, of course, using the discrete formula of me. Okay, so this one, my case, in fact, equal means that x equal 1. This one is meaning that, okay, what is it? Okay, this is equivalent that alpha is equal, or x whatsoever, the exact roots. Okay, equal 1 is a root, is an exact root. And exactly, Mr. Murat. Okay. Of order multiplicity of order of order of multiplicity equal of order multiplicity 11 here and equal 11. Thank you for listening and we see inshallah see you next time. I'm going to okay this one. This is me, Mourad Sultan Ezouidi. Thank you and goodbye. Okay, I will close this. Yes, close this. Of course, close this one. So this is also is my book of mathematics. I have published it, okay, and you can buy it. Okay, it's not too expensive. It's cheap, maybe 17 or $15. Okay, and if you want, let's say one copy, just contact me. I will sell it for you. Thank you and goodbye. Okay, now I'll come here. Okay, no, cancel. Not now. Okay, thank you for listening. And this is Mourad Sultan Ezouidi, the pioneer in the mathematics and the researcher in the field.